All right, Chem 30, let's continue on with our organic chem functional groups. We're talking about the ethers today. Ethers, ether, E-T-H-E-R-S, ether, not ether, not eithers. It's ethers, okay? An ether is an organic compound containing oxygen, okay? An oxygen atom bonded to two carbon atoms. An oxygen atom bonded to two carbon atoms like you see over here on the right. Ethers have the general formula of ROR prime. So remember R is a carbon chain or ring. And R and R prime would be, they could be the same, but they could be different as well. Most likely, a lot of times they're different. So you could have an ethyl on this side and a methyl on the other side or whatever. So on the right here, I've just kind of highlighted what makes an ether an ether. We have an oxygen singly bonded to two carbons, and I kind of like to think of it this way. There's a carbon on either side of the oxygen. If you remember that, it will help separate, the structure of these groups. A carbon on either side. There's a carbon on either side. Kind of like either side, right? But either side. Nice. Isn't that great? That's great. I'm pretty sure I'm the first one in the world to come up with that. So we'll give, sure. Right. All right. So naming ethers. When naming ethers that have two identical alkyl chains, remember alkyl chains are the carbon chains, singly bonded to oxygen, first name the alkyl group and then add the word ether. So if we have the exact same things, if it's really like ROR, where R's are the same, then it's pretty easy. You name the alkyl group, and remember I did highlight this YL here for you. So instead of saying propane ether, you're considering these chains as functional groups, okay? Sort of thing. So it's propyl. Propyl ether. Why is it propyl? Well, meth, eth, propyl. Meth, eth, prop. So MEP. 1 would be meth, 2 would be eth, 3 is prop. Meth, eth, prop, bute. So this is propyl ether because it's the same on both sides. Question?
Wouldn't it be propyl?
No, it's propyl, not propyl. Propyl. Good question, but no, it's propyl. Okay? What about this one? Well, what's the group here? It's a cyclo, right? Even though it's a hexagon, we talked about this yesterday. A cyclo with 3 carbons looks like a triangle. Yes, it's not a circle. But we still call it cyclo because it's in a chain that comes around and connects to itself. So these are both the same, cyclohexyl ether. Or like I like to call it the Star Wars TIE Fighter molecule. Does that not scream Star Wars TIE Fighter?
That's not TIE Fighter. That's a different one. That's where the bomb was.
Darth Vader is in there, right there. Darth Vader is in here.
Except that you're forgetting that it's only
No.
You want me to? I can look.
No, you're wrong. That is exactly what a TIE Fighter looks like. What? I knew that this would start a hot debate. Just mention Star Wars and yeah.
TIE Fighters are H-shaped.
Oh, this is perfect right here.
That's either the bomber.
Okay, all right. Okay, that was our little brain break there. All right, let's keep going. Yes, question? Why is it YL? Because this is a functional group. It's part of the alkyl functional group. So you would name it as propyl, not propane. Propyl. Yeah. So the prop comes from the number of carbons, and then it's a YL. Now I did put this on here just for us. You might see it. You might, again, remember we talked yesterday about organic chemistry is a very huge field. It's universal. There's a lot of different people doing different things, making different publications, almost kind of like, in a sense, redefining things. There is supposed to be an international IUPAC, International Union of Pure and Applied Chemistry set of rules. However, you may see on the internet or in your textbook, I don't know about this textbook, but you may see dipropyl ether. That is not wrong. It is not necessary, but it is not wrong. So if you do dicyclohexyl ether, you might see that somewhere, and that is acceptable as well. I would strongly suggest that, like I say, I'll just try and teach the main way and try and stick with that because it's just easier to remember, okay? So if you see dipropyl ether, don't cry foul and say, oh, Mr. Maxwell's lying to us. It's both have been used. And again, when you look up things on the internet, right? You could look up things that are totally wrong and you'll find somebody has written about it. Somebody else has got it wrong too. So don't say, oh, I found it on the internet. It's got to be right. Well, it doesn't have to be. If there's 57,000 hits on propyl ether and 3 hits on dipropyl ether, you might think that maybe this is not quite accurate. So yeah, you can find anything on the internet. Okie dokie. Any questions there? Ane is single bonds.
What is
Ene.
eel mean?
Okay. Okay. The eel was back in the notes from the other day. We talked about the alkyl group. So if 2 alkyl groups are different, okay, so now they're different, the groups are listed alphabetically and then followed by the word ether. So again, what makes this an ether is we have an oxygen and there's carbon or carbon chains on either side, right? Single bonds, all that sort of stuff. So this is an ether. What you do is if these are just, straight carbon chains, which is, the easiest of the most common, then what you're going to do is you're going to name these functional groups, these straight chain functional groups, in order alphabetically. So this is ethyl right here, an ethyl group. This is a butyl. Meth, eth, prop, but. So you'd list the butyl first, and you would call it butyl, ethyl, ether. Butyl, ethyl, ether. That's the name of this one. So think alphabetically as well. This one over here, this is ethyl. This is methyl. So we're going to go ethyl, methyl, ether. An ethyl, methyl, ether. Okay. All right. We'll get some practice naming after we talk about properties and uses. So the term ether was first used in chemistry as a name for ethyl ether, the volatile, highly flammable substance that was commonly used as an anesthetic in surgery from 1842 until the 20th century. So an anesthetic, like anesthesia, like to put you out, right, to knock you out, or at least to put you in a state where you're not feeling all that they're cutting off. Because ethers have no hydrogen atoms bonded to the oxygen atom, their molecules cannot form hydrogen bonds with each other. Therefore, ethers are generally more volatile and have a much lower boiling point than alcohols of similar size. So there's a lack of hydrogen bonding, and so the boiling point is pretty low. These will escape into the gas phase without a whole lot of energy comparatively, compared to alcohols and those kind of things. So lower boiling point because of the lack of hydrogen bonds, hydrogen bonding. Ethers are much less soluble in water than alcohols because they have no hydrogen to donate to a hydrogen bond, but the oxygen can act as a hydrogen bond receptor. So, ooh, that didn't sound good out there. Ethers are much less soluble. So the solubility is low for ethers. So low boiling point, low solubility. Low boiling point, low solubility. And an ancient anesthetic, I guess. Okay. All right. Okay, so there's the TIE fighter. There's the TIE fighter. This is a former student, of course. Okay. That is Carson, yes. Yeah, hello, Carson. Okay. All right, so I'm going to clear the screen here, and I'm going to get you to... All right, so these are the ones that you're asked to name.
You're still frozen.
And of course, there's the TIE fighters. That's right, Mr. Maxwell, just kicking it here. Boom, boom. Yeah. They're green lasers? Oh, my apologies. Sorry. Let's see if I can find some green lasers there. Let's make them pretty big. Okay. This is a cyclohexyl ether fighter. Didn't you say there was 8 sides? Wrong. 6. Cyclohexyl ether fighter. Okay, let's name these guys here. All right, here we go. Name the following ethers. Well, we have an ethyl on both sides. It's identical. So you could call it a diethyl ether or just ethyl ether. Diethyl or ethyl ether. Diethyl ether or ethyl ether. Say that fast 10 times. Yeah, that's right, you can't. That's tough. Tongue twister. Okay, what about this one? Well, we have a methyl and we have a meth-eth-pro-but. We have a butyl. So B comes before M, so we'll go butyl methyl ether. Butyl methyl ether. Well, that was C, I guess. B, down over here. So this is the same on both sides, so we only have to name it once. What is it? It's a meth-eth-prop-but. It's cyclobutyl ether. It wouldn't be wrong to put di in front of there, but you don't have to. All right, so here you might have a question about this one. What about the cyclo part? Okay, does the cyclo count as alphabetical or not? I believe that, again, according to most of the convention that I can find out there, why is there a either? The cyclo is usually mentioned first. So if you have a cyclo, put that on there first. Cyclo, meth-eth-prop, cyclopropyl, ethyl, ether. So cyclo first, make that as a note. So it's alphabetical except when you have a cyclo. And we'll list that first. And again, that's just seeming convention that I can find in most textbooks and publications. Yeah, question? Is it a hydrogen, did you say? Hyphen. Between, like here? No, this here? No, that's just the YL. Cyclopropyl ethyl ether. Why do I write so weird? What are you talking about? What? What end part? What are you talking about?
Y and L.
What about the YL? Huh? It looks different? Y and L. Propyl.
Oh.
Anyways, okay. Cyclopropyl ethyl ether. Okay. Any questions about those? All right, draw these. Methyl ether, cyclobutyl methyl ether, butyl pentyl ether, methyl propyl ether. You want to sound like a madman? Just say these kind of organic chemicals just as you're walking down the street. Methyl ethyl ether, cyclobutyl methyl ether, butyl pentyl ether, methyl propyl ether. Just do that. I dare you. I encourage you. And watch the reactions. Yeah. All right, so to finish off our lesson here, this is the last thing we need to do here today. To draw these. Now you have a variety of different options to draw them, right? Sort of the condensed structural formula here where you have some bonds and you have some just letters written side by side. So methyl ether, you have a methyl group on either side. Okay? Methyl on either side is what it looks like. Cyclobutyl, meth-eth-prop-but, that's 4. So it's kind of a square, a little bit of a diamond, whatever, attached to the O, attached to CH3. Butyl pentyl. So butyl has 4, pentyl has 5. So we have 5 straight chain, 5 carbons and 4 carbons. Please note, I highlighted this. There's a CH3 on either end. These are all CH2s in here. CH3 on the end, CH2s in the middle. Okay. And then if you're going to draw a full structure with all of the bonds like this, methyl propyl ether. Methyl is just a 1 carbon on one side. The propyl is meth-eth-prop. That's 3. And so here you go. You've got your carbons. Remember to draw 3 on the outside, so the carbon has 4 bonds always. The oxygen just shows 2 bonds, but we have unpaired electrons then there, right? That's all that means. And so inside there is CH2, and then another CH3 on the outside. Question? Divine? Great. No. Again, it doesn't matter which side you draw them on. Doesn't matter. You have to name them in alphabetical order sort of thing, but you don't have to draw them because it's one side or the other. It doesn't matter. It might be easier to keep the meth if that's written first, put that on the left, and then the pro, you know, on the right. But other question? Or was that your question? Yeah. So that's your ether lesson today, and I'm going to give you assignment number 1. You can find assignment number 1 on MrMathWell.com. Organic assignment number 1. This is the one we're going to be doing here now. So if you lose this one, have to reprint, or want to take a look at a digital copy, here's one right here on MrMathWell.com.